So obviously, when you drag a file into the recycling bin, it's not actually deleted because you can go in that folder and then take the file right out. And even when you empty the recycling bin, there's file recovery programs that you can use to get those files back. So how can you delete a file permanently? In film and TV series, you'll often see people destroy data by putting the media in a microwave or physically destroying the device that holds the sensitive data on it in some other way. And this works if done correctly, but modern solid state drives are pretty resistant to impact damage, so smashing a computer or even running the drive over with a car might not render the data that's on it unreadable. So you really need to make sure that the device is severely burnt in pieces or have some holes drilled through the center of the drive in order to be totally sure it's unreadable if you're throwing it away. Now, what about if you're selling a computer to someone? You probably want to keep the drive intact so that the computer is ready for your buyer to use. And of course, you don't want them getting your data. So you might be tempted to just factory reset the machine or maybe even format the hard drive so that the new user can install their own OS to it. But neither of those approaches actually securely delete data. Those processes just mark the sectors on your hard drive as available to have new data written to them. And even though the factory reset is reinstalling the operating system, all of the sectors that contained your user data are not going to be overwritten by the OS. So the new owner could still recover some of your sensitive information from that drive with a file recovery tool. Now, one way to avoid this problem, and a way that can also help you erase files in an emergency, is to use full disk encryption on the drive from the very beginning. Because then if you reformat or if you factory reset the device, then the sectors on that drive that might still contain your data are storing it in an encrypted form. So there's nothing that anyone can do with it unless they also have your encryption password. And even if they do have your encryption password, they would have to recover the LUKS header that actually contains the decryption keys. So without that, the data is truly lost forever. Now, if your data wasn't encrypted, then you're going to want to erase and then do a full overwrite of the drive. And the exact process to do that really depends on what type of drive you're erasing. Modern NVMe and solid state drives have support for hardware-based encryption by default, and this can be a little confusing, especially if you haven't actually set up a password for your self-encrypting drive. But basically, there's a default master key that's going to be configured on the device that's always on, and the data is always encrypted with it, but that master key is unsealed if you haven't set a password for it. But if you use a utility like NVMe Format on Linux, you can perform a cryptographic erase of these self-encrypted drives, which destroys or change those original master keys, making the encrypted data on the drive inaccessible. Now, one thing to consider about these self-encrypting drives is that the implementation of the encryption is done in the device's firmware and is usually proprietary. There's also been multiple instances where self-encrypting drives from different vendors have been hacked into to retrieve user data successfully. So this is one of the many reasons why you should go with a more reputable brand when buying new storage devices, and of course, using open source encryption whenever possible, even if the firmware-based encryption promises better performance on the device. NVMe CLI also has an option to erase user data and then overwrite it with random bytes, which is generally considered sufficient for deleting user data on most modern NVMe devices. Now, since we're talking about overwriting data, let's discuss the necessary number of passes. So you may have heard of the Gutmann method or seen it as an option in secure array software, which does 35 overwrites in total using different patterns when doing the overwrites on a drive. And this secure erase algorithm was devised in the mid 90s, and the purpose of it was to delete data from a storage medium that the user doesn't know anything about the encoding of. So To summarize, the Goodman method is really just for worst case scenarios where you need to securely erase data on very old hard drives. And even Gutman himself has said that most of the patterns that are used in his algorithm are actually irrelevant to the encoding techniques that modern drives use. So pretty much everything but the random passes are just going to be wasting your time with using this method to secure erase a device. But you should keep it in your back pocket just in case you do need to do a secure erase on a 5.25-inch floppy disk anytime soon. Some other older secure erase algorithms are the DoD 3-pass and 7-pass methods, which first fill the entire drive or the sectors containing a file or folders with zeros, and then writes all ones over that, and then does a random byte run. And the 7-pass method basically does the 3-pass method twice with an extra random run in between. These methods were deprecated as of 2001 and were also never fully certified for flash storage to my knowledge. But generally, a single pass is considered acceptable for making data unretrievable from modern spinning Rust drives. However, it's important to always verify that data cannot be recovered by inspecting the raw bytes of your hard drive after you've done a secure erase, no matter how many times you have overwritten the drive. Now, speaking of flash storage, most devices that were manufactured in the last 10 years or so should support ATA Secure Erase or the newer Opal specification for securely erasing a drive by deleting the default encryption key on it. And if a solid-state drive doesn't have this feature, then it's basically impossible to securely erase plain text data from it, meaning data that was never stored on it in an encrypted fashion. The process of filling sectors on a drive with zeros or random bytes to delete sensitive data doesn't work on an SSD because they use wear leveling, which distributes writes across different cells on the disk. And oftentimes, there's cells that are reserved for this wear leveling that are inaccessible to conventional user space tools, but may be accessible to proprietary file recovery tools. So doing multiple overwrites on an SSD isn't going to do anything but reduce the lifetime of the drive. And even for the devices that do support ATA and Opal security implementations, it's important to make sure that the firmware of those devices is up to date, because there's been multiple cases where the implementation of these security features was flawed and data was able to be recovered from the drive. And this has even been the case with mainstream flash storage vendors like SanDisk and Samsung. But since these secure erase procedures can still take several minutes even on modern drives and can be difficult to trust depending on the implementation, which is usually a proprietary one, the best overall secure data erasure method is to have your files encrypted on disk, either using full disk encryption like LUKS or file system encryption like FSCrypt. And the reason I recommend these over the firmware-based encryption or BitLocker is because these are open source. Even though all of these different encryption methods claim to use AES, LUKS is the only one with a fully transparent implementation that you can inspect yourself to make sure it doesn't contain any backdoors or weaknesses like the ones that have been discovered in the self-encrypting drives in the past. So in conclusion, the only ways that your data can ever truly be deleted from a drive is to encrypt it with an open source lock from the get-go and then throw away the key, or physically destroy the drive, which is going to damage it and possibly your microwave too. If you enjoyed this video, please like and share it to hack the algorithm, and check out my online store, based.win, where you can buy my awesome merch and accessories for your phone or laptop. 10% store-wide discount when you pay with Monero XMR at checkout. Have a great rest of your day.